All right, let's take a look at 731 together. We're just going to take it easy today. I think we're going to get a little more done this way on a Monday than maybe something else. So let's just do title of our paper, 731, and let's look at 104. If dy dx equals x, then what does y equal? And is there more than one possible solution? So what does dy dx represent? So it says if the derivative equals x, what was y? And I feel like this is a question I could have asked you months ago, and you would have told me, well, if the derivative is x, the antiderivative should be something with an x squared. And I think that should start making sense. And then we know from taking antiderivatives that it should also have that 1/2 or divided by 2 there. So can you see it now? If I derive y, which is 1/2 x squared, do I get x? Sure. And then the other part of the question was, is there more than one possible solution? What do you think? What if I put a plus 5 here? Does my derivative change at all? No, right? Because the derivative of 5 is 0. So that is where we can antiderive, and we always need that plus c. Y equals 1/2 x squared plus c. There's an infinite amount of constants that we can put there and come up with that as our derivative. So this is what this is going to look like. For 105, we're just going to look at it and say, okay, what derivative gave me that? So take a look at 105 and see if you can predict a little bit. So 105, if the derivative was 6 cosine x, what was the function? What function gives me a derivative of cosine? That would be sine, and then plus c. What function gave me a derivative of x cubed? You bet. No problem there. Now, what function gave me a derivative of y? All right, so here's your process. We want to, and this is called separation of variables. We want to get all the y's on this side and all the x's on this side. And this is always the case. So I'm going to multiply the dx over. If I multiply the dx over, I'm going to have y times dx. How am I going to get this y over to the other side? I'm going to divide it. So I'm going to have dy over y equals dx. Now that I've separated the variables, now I'm going to integrate both sides. Now it should make sense over on this side to integrate 1 times dx. That integral is just going to be x. Now what's going on over here? And we're getting good with our x's. We got to remember that a's and b's and y's are all just letters as well. So I would probably encourage you to rewrite this one over here as 1 over y times dy. That tends to make more sense. What is the integral of 1 over y? That is the natural log of y. So we haven't got y by itself yet, but we're going to save the rest of this problem. It's like a special problem. We're going to save that. The important thing is, what are we looking for? What derivative gave me this? what derivative gave me this. So we've got a fundamental understanding of, and these are called differential equations now. Now we're getting into like real math. So I'm going to walk you through the math notes box, but it's actually the exact same problem as 104. You already know what the answer is. Now let's make it make sense in terms of the actual process of solving a differential equation. So dy dx equals x. Always separate the differentials, or I call it separate the variables. That's what you're going to read. So separate the variables. And in this case, we only have to multiply the dx over, and we have separated them. We have x on this side with its dx, and we have y on this side. Always the next step is to integrate both sides. And I think we should start seeing that the integral of dy is just y. And you'll see, we've talked about this a little bit last week, but this c1, the integral of x, is x squared over 2, or 1/2 x squared, plus c2. And really we're done. And this is that understanding of a constant plus a constant minus a constant is always just going to be c. So we'll finish this problem as y equals x squared over 2 plus c. We don't even have to call it c3 or c whatever. It is just c. That is our answer. All right, we're going to do 2 more problems. We're going to kind of go off the board a little bit. dy dx equals x times y. So the derivative of something gave me x times y. So I can find the slopes of my function at any point. So let's go ahead and do our separation of variables. I need all the x's on this side, all the y's on this side. First thing I'll do is multiply the dx over. Now I've still got this y here, so I've got to divide it over. And again, as I integrate these things, I am going to write that as 1 over y dy equals x dx. So I'm going to go up to the next line, and these problems tend to take, you know, a good half paper when we get to some good ones. And one of these problems will be a long AP question that's worth about 4 or 5, maybe 6 points on some of them. So what is the integral of 1 over y? That is the natural log of y. And it's a good process to put that c on both sides. It's just showing an understanding that when I integrate this side, I get a constant. When I integrate this side, I get a constant. And then we're going to subtract it over and get the c on the other side anyway. All right, here we go. This is where, like, you really got to pay attention. Some kind of deep pre-calc algebra going on here. I'm going to subtract this c1 over, or add it over, whatever we call it. So we just have our 1c over here. Natural log of the absolute value of y equals x squared over 2 plus c. Now, we have the absolute value because, you know, up here, y could have been anything, but we can't take the natural log of any negative numbers, so we need an absolute value there. Now, here's where the magic happens. Ready? The natural log is log base e. And we learned a long time ago, if I do one thing to one side, I can do it to the other side. It is always convenient to take both sides underneath an e power. So I've got e to this power and e to this entire power. And you'll see why this is convenient in just a second. So we've got that. Now, okay, here's your Algebra 2 background on the next thing I'm going to do. If I have e to any natural log, it always equals whatever is right there. And I'll show you why. I'm saying this is going to equal 5, but I'm going to call that a. If I take the log of this, and I write log base e of a equals the natural log of 5. Natural log is log base e, so then I really have a equals 5. And I told you that was going to be 5 anyway. If I have e to the natural log of junk again, it's obviously just going to be the junk gets to come down. That's the convenient thing about this next step up here. So if I have e to the natural log of the absolute value of y, and if you need more of that algebra 2, I mean, I can definitely show you that. So what I'm saying is e to the natural log of y is just y. Now over here, remember when we have, let's call it b to the m plus n, we can write that as b to the m times b to the n. So what we typically do on this problem is we write this as e to the x squared over 2 times e to the c. The next thing that happens here is e to the c, and you're gonna laugh, but e to the c is another constant. So we actually just take this whole thing and call it another constant. So this e to the c becomes c e to the x squared over 2. Now, back to this absolute value. If I have the absolute value of y equals e to some power, we know that e to any power is always going to be greater than 0, because even if I put a negative 100 in here, it's going to be 1 over e to the 100, which is still greater than 0. So at this point, we can actually just lose the absolute value, because we understand that whatever y was, it's going to be positive anyway. So it's going to be y equals c e to the x squared over 2. I know that seems a little overwhelming, but you've got this. Let's try one more. How about this one just be just a touch easier? dy dx equals 7y. This is a lot like that number 105 we were looking at. Get the dx over, get the y over. Now, a pretty common mistake is to divide by the 7y, but we really just want to divide by the y and leave the 7 over here with the dx. It just ends up being a lot more convenient. And if you put the 7 over here, it ends up being very inconvenient. So leave the 7 over here, put the y over here. You're going to get very used to doing these problems and seeing y on the bottom and understanding that that is the natural log of y plus c equals 7x plus c. Add the c over, natural log of y equals 7x plus c. Now we're going through this one a little quicker. The next step is always e to both sides. This is convenient. E to the natural log of anything is just the anything. Now, again, this is e to the 7x times e to the c. E to the c is just c e to the 7x. And again, because it's e to anything, it's always going to be positive, so we lose the absolute value, and we call it good.